Okay, so let's shift gears and talk about merging data. Oftentimes when you're conducting an empirical analysis, your data is scattered across different tables or different data sets. So for example, you are combining income data and health records. Your health records come from medical data, whereas your income data might come from a tax file, for example, and therefore you would need to combine the health records and the income for the same person from these two files. So, and R provides you different functions to merge data. So the first one that we're going to look at is the so-called left join. And the left join lets you combine a dataset A with a dataset B, and it keeps everything from dataset A, so from the left dataset, and just appends the columns from dataset B for these observations that could be found in both the dataset A and the dataset B. For all the observations in dataset B that could not be matched to an observation in dataset A, they will just be deleted. The inner join will append columns together, but it will only keep the observations that could be identified in both data sets. So it will only take the intersection of these two data sets and delete all the observations that only appeared in one of the two data sets. The semi-join is not really a merge command, but rather a filtering command. So it will keep only the observations from dataset A that could be found in dataset B as well, but it will not merge the columns from dataset B. It just filters whether an observation in dataset A appeared in dataset B, and if yes, it keeps it. If no, it will delete it. The anti-join is also a filtering command. It will just do the exact opposite. It will check whether an observation in dataset A appears in dataset B, and if so, it will delete it, and it will only keep those who do not appear in dataset B. So let's look at some examples. Something else I need to mention is that when you're merging dataset, you always need to provide keys. So you need to provide unique identifiers such that R knows with certainty that a observation dataset A corresponds to a certain observation dataset B. And sometimes you have unique identifiers. For example, in cross-sectional data, the person might have an identifier in each of the data sets, and these identifiers are unique. For example, but if you're looking, for example, at panel data, the same person might appear several times. So in order to merge, you need to provide kind of two pieces of information to uniquely identify the matching observations. You need to provide an identifier, it's like a person ID, and a year, and combined, this creates a unique identifier that allows you to match an observation from panel A to an observation in panel B. Sometimes you also would like to merge data sets, but the variables that serve as identifiers have different names in the two data sets. And you could either, of course, just rename them, or you can just provide like any of these join functions, where join function here is just general for all the ones that we just mentioned, where you give as arguments dataset X, dataset Y, and then you say by which variables you would like to merge. And here you should specify that in dataset X, the unique identifier has this name, and it should correspond to the identifier Y in the dataset Y. So in the left join, now let's look at some examples. You would type the two datasets that you would like to merge. So you have the dataset X, which is the dataset A, from which we're going to keep all observations, and dataset Y, and then you provide the key that is present in both of these datasets, and according to which you want to match the observations. If you have multiple keys, you just provide a vector of these multiple keys. So as you mentioned before, for example, you might need to supply an identifier and a year to uniquely identify the observations in both. data sets. So let's look at two examples, or two data sets. We have earnings and we have education, and both have three observations. Earnings has person 1, 2, and 3, and education has person 1, 3, and 4. And we can see that person 4 only appears in the dataset education, and person 2 only appears in dataset earnings. So this will show us how these different merge functions combine data. So now let's look at the left join. The left join, as already mentioned, keeps all the observations from the dataset earnings, but it will only keep the observations from dataset education if it could find a corresponding observation in the earnings dataset. So if we use the left join here and we match by person ID, then we keep person 1, 2, and 3, because these are all the ones that appeared here, right? But then since person 2 did not appear in the education dataset, is 1, 3, and 4, we do not have schooling information, but we still keep this observation. We just the command just fills this data with missing value. And for person 1 and person 3, these appear in both the earnings and the education dataset. It will then append the schooling, the years of schooling to these observations. So as you can see here, now we have wage and schooling. And for person 2, we keep it, but we do not have the years of schooling. Now, if we use an inner join, this would only keep the observations that appear in both data sets. And as a consequence, this would only return us kind of complete data sets. So in this case, since we're only keeping observation 3 and 1, if you look at here, 3 and 1 appear in both data sets, 2 and 4 only appear in one of the data sets. We therefore have 2 observations left, but both of them are complete. If we would keep any other observations in the data set, this would mean that either schooling or wage would be missing. And the inner join only keeps complete observations. The semi-join then is, as I already mentioned, it is basically just filtering, and it only keeps observations from dataset A that appear in dataset B as well, but it does not append the variable from dataset B. So here you can see that we also kept the 2 observations from in the inner join, the observation 1 and 3, and we have the wage, but we do not have the schooling here, because semi-join is not a merge command. It just filters for whether these observations also appear in the other data set. And consequently, the anti-join, who does the opposite, it just filters for observations in earnings that do not appear in education, and that's only person 2, and also does not append any data. So now we're just left with the wage of person 2. If you just want to append data in the sense of you would like to combine additional observations to your data set, you use the function bind rows, and then you just provide a list of the data frames that you would like to have combined. And what this does, it basically just stacks your data set on top of each other. So for example, if you have a panel and you would like to append an extra year, then you would just use bind rows to append the extra rows that contain the observations for a new year.